hopefully some more people will join us. So yeah, I just want to welcome you all to our first installment of our four-part Winter Speakers series that's going to focus on collaborations that Hawk Ridge has been doing with other organizations. So it looks like we've got a lot of people who might be familiar with Hawk Ridge, but just to give you a little bit of background, if you're not familiar with Hawk Ridge, Hawk Ridge Bird Observatory is a nonprofit organization in Duluth, Minnesota, whose mission is to promote the conservation of raptors and other birds in the Western Great Lakes region through research, education, and stewardship. We historically started as a fall migration site, but we have expanded our reach to most of the year and are always expanding. We are a nonprofit organization, and therefore we rely on our members and our donors to be able to continue the work to support our mission. And we thank you all for that support. A few housekeeping things before we get started. I'll just ask that you all remain muted during the presentation. We are recording the presentation today to share on our YouTube channel. So if you miss anything, you can catch it later. We will have time for questions at the end of the presentation today, and you can either type those into the chat while we go or at the end. And then at the end of the presentation, if you want to unmute yourself and ask a question, you can also do that then. There also should be closed captioning on this presentation. So if you go down to the bottom of your screen, you can see show or hide captions if that is something that is needed for you. And then we'll wrap up here around 7 o'clock. So today we're going to hear from Dr. Dana Franzen-Klein, who is the medical director at the Raptor Center, and she's also an instructor at the University of Minnesota College of Veterinary Medicine. She does a lot of different things for her job, including providing medical care for raptor patients, managing a wellness program for all of their captive educational raptors, teaching and mentoring students, leading various research projects, and working on publications, and I'm sure many, many other things. Um, the Raptor Center has been a really incredible partner to work with over the years on various research projects, and we're really excited to be partnering with them currently to study and document the incident of highly pathogenic avian influenza in raptors, which is what Dana is going to talk about today. So without further ado, thank you, Dana, for being here today to talk about this important work, and I'll hand it over to you.
Thanks, Emily. Thank you for inviting me. It's great to be able to share what we've been doing with you all, with our broader community. So the Raptor Center, we're down in St. Paul, Minnesota. Our primary work is our wildlife rehabilitation hospital. So we take in over 1,000 injured, sick, and orphaned raptors on an annual basis and treat them with the goal of releasing them back to the wild. We also have a public education component to what we do. So we have non-releasable raptor ambassadors that the public can come and visit, or they travel out to schools to teach people about raptors and what they can do to help protect the environment that we share with them. And then another component of what we do at the Raptor Center is research, focusing on raptor health and ecosystem health. So this project is part of our research work. So it's a highly pathogenic avian influenza serosurveillance that we're doing with our wildlife rehabilitation patients at the Raptor Center. And we've also partnered with Emily and her great team at Hawk Ridge as well. So we'll start with our time today with an introduction to avian influenza viruses, give a summary of the current highly pathogenic avian influenza outbreak, and a high-level overview of the objectives of this research work. And then I'll provide a summary of the results that we have completed to date, and then we'll end with a discussion of what these results can tell us about highly pathogenic avian influenza in our native raptor species in Minnesota. So let's start at the beginning of an overview of influenza viruses. So all influenza viruses are divided into four main categories: type A, type B, type C, and type D. Type A includes our human seasonal influenza viruses, as well as all of the types of avian influenza viruses. People can also get type B influenza viruses as well. Type C influenza viruses can infect people, but they're pretty uncommon. And then type D influenza viruses affect cattle and swine primarily. So our focus today are those avian influenza viruses, which are a type A influenza virus. All influenza viruses, including avian influenza viruses, can be further categorized into what are called subtypes. So, influenza viruses have two types of proteins on the outside surface of that virus, and those proteins play a role in how that virus interacts with its potential host. So these proteins are called hemagglutinin, which is abbreviated with the letter H or HA, and neuraminidase, which is abbreviated N or NA. These surface proteins come in different variations, and these variations are assigned numbers to identify them. So there are at least 16 different subtypes of the hemagglutinin or the H protein, and 11 subtypes of the neuraminidase or the N protein. And then influenza viruses are evaluated to see which of the surface proteins that specific virus has. And then that letter number combination of the surface proteins is used to name the influenza virus subtype. There we go. So, for example, the highly pathogenic strain of avian influenza virus that's causing the current outbreak in wildlife is H5N1 virus. Avian influenza viruses are further separated based on their pathogenicity in domestic poultry. So, what that means, the type of clinical disease they cause in domestic poultry or chickens. Low pathogenic avian influenza viruses cause mild to no disease in domestic poultry. They can be any of the H subtypes, including H5 and H7. And those H numbers, so those H5, H7 numbers, those can be low pathogenic strains as well. And low pathogenic avian influenza viruses are very common in wild birds. Highly pathogenic avian influenza viruses, which are abbreviated HPAI for short, those viruses cause very severe disease and high mortality in domestic poultry, so chickens and turkeys. They do not always cause the same severity of disease in wild birds, however. Waterfowl and shorebirds, especially, can be infected with some strains of HPAI and not get sick at all from the virus. So the high path strains are either H5 or H7. That's kind of your only two options for HPAI viruses. And high path AI viruses previously were very uncommon in wild birds, but that's changed with this current outbreak. Because highly pathogenic strains of avian influenza are so devastating to the domestic poultry and agriculture industry, and these viruses can spread very easily and very quickly, HPAI is highly regulated and it's flagged as what's called a foreign animal disease. So this means there's very strict regulations about how to respond to this disease and prevent its spread when it is found in domestic poultry. So this is a graphical depiction of the disease ecology of avian influenza viruses. So disease ecology looks at a disease at a very high level and kind of from all different angles and perspectives. It evaluates where the disease comes from, how the disease spreads throughout the ecosystem, how it spreads between individuals, and how it impacts the people and animals that are infected with the disease. Highly pathogenic avian influenza viruses first arose in domestic poultry, that's where it started, and then it spilled over from the ag industry into wild birds a long time ago. And after that initial spillover event from the agriculture industry into wildlife, there's now a two-way direction of disease spread back and forth from wild birds to the agriculture industry and vice versa. HPAI viruses are also zoonotic, meaning people can contract the disease from animals and become sick, but humans are dead-end hosts. So that means if a human gets sick from any of the current circulating high path AI strains, they don't spread it to other individuals. So, this current outbreak of HPAI that's been circulating throughout the world, including North America, is characterized as an H5N1 clade 2344B virus. So, the viral clade is an even more specific subdivision of that viral strain. And viral clades can be even further divided into specific genotypes, which are named by letter and number combinations. So you might see something like H5N1 clade 2344B, genotype A3 or D11. So this virus began circulating in Europe in October of 2020. The first detection of this specific virus in North America occurred in December of 2021 in domestic poultry flocks in Newfoundland and Labrador, Canada, which is circled in red on this map. So these poultry were believed to have been exposed to the virus by migratory waterfowl that came to the area from Europe, and their suspected migration route of the wild birds is marked with the red arrows. So, after arriving on the east coast of Canada, the virus very rapidly traveled down the east coast of the US within wild bird populations and was detected in the US in January of 2022. And it also very quickly spread westward, entering multiple migratory flyways. And this virus was first detected in Minnesota on March 16th of 2022. The first positive wild bird was a great horned owl from Candy, Ohio County. It was not sampled by the Raptor Center, but it was the first bird found in Minnesota. So this map is from the USDA APHIS website, and it depicts the number of individual wild birds that have confirmed positive for HPAI from December 30th, 2021 through December 9th, 2025. And Minnesota has the highest number of wild bird detections in the United States at 1,003 individuals. So our high count is likely related to the more extensive wildlife surveillance that's being conducted by our state. That's being done by us at the Raptor Center and other organizations as well. So this map lists the total number of HPAI positive wild bird samples in the US as 16,651 individual birds. But we know this is a dramatic underestimate of the actual total number of wild birds that have been infected by this virus. So this is just the number of positive tests. There's inherent limitations to wildlife surveillance, including the conditions in the natural environment, which limits our ability to find all birds that have been infected with the virus, remote areas where birds may have succumbed to the disease, so they aren't found and they aren't reported. And then there's an inability to test every individual bird in a mass die-off. So if there's 100 or more dead birds, they may only test 5. So that really drops the counts quite a bit lower. There's also varied clinical presentations of this disease among different species of birds, so that can influence on whether testing is done or not. And the current strain of HPAI is behaving very differently than previous high path strains in a few different ways. So, in previous HPAI outbreaks in North America, the virus would circulate in wild birds and domestic poultry for one migration season, and then it would disappear from the environment. This current strain has been consistently circulating in wild birds and the agriculture industry in the United States since early 2022. So we're at nearly 4 years at this point. And this strain of H5N1 has caused significant illness and mortality in waterfowl and shorebird species. So other clades of H5 high path AI viruses have circulated in waterfowl and shorebirds without causing any significant illness. This strain is different. It's causing a large amount of illness and death in those species. And the virus has also spread to multiple mammalian species, causing illness and death in some individuals, which has never been seen with previous high path AI outbreaks. So, some but not all of the mammal species are pictured here on the slide. So, you have bobcats, black bears, bottlenose dolphins, raccoons, fox, possums, skunks, minks, and then seals and sea lions as well. So now that we've kind of talked about what high path AI is and described the characteristics of the current ongoing outbreak, let's move on to discussing the purpose of the HPAI research being conducted by the Raptor Center with collaboration from Hawk Ridge Bird Observatory. So, the overarching goal of our high path avian influenza research is to understand the disease epidemiology of this specific strain of HPAI in North American raptor species. So, epidemiology is a science that focuses on exactly how an infectious disease impacts a population. How does the disease spread? How do infection patterns change over time? And what overall impact does the disease have on the population? To understand disease epidemiology, there are two types of disease surveillance or disease testing that we can do. So, the first is looking for active infection, meaning the bird is currently infected and sick with the HPAI virus at the time of sample collection. So, this component of disease surveillance is done with polymerase chain reaction or PCR testing. So, the sample is collected by taking a swab, and is shed when birds are infected. And that swab sample is then placed into a liquid medium, and that liquid has the PCR test done on it. So PCR testing looks for genetic material of the virus within that liquid. So in the case of influenza viruses, it's looking for viral RNA. So at the Raptor Center since March of 2022, we have been obtaining a sample for avian influenza PCR testing on every single wild bird that's admitted into our hospital. So we are testing birds that are showing clinical signs of HPAI and birds who are not. We're testing birds who are admitted to the hospital for treatment and birds that unfortunately must be euthanized at the time of admission due to the severity of their injuries or illness. And we're testing birds that arrive deceased. So, this type of complete disease surveillance, where we are testing every single wild raptor admitted to our hospital, gives us a very robust representation of disease prevalence in the population of birds we are seeing in our hospital. And we collected PCR samples from birds at Hawk Ridge who were enrolled in this study in the fall of 2023 and 2025. The second type of testing that is done to evaluate disease epidemiology is called serology testing or serosurveillance. So, serology testing looks in the blood for antibodies to the infectious agent of interest. So, if the test is positive, that indicates that the animal was previously infected with the disease. Their immune system responded to that infection, and the immune system produced a protective protein called an antibody that we can look for in the blood. So, we've been collecting blood samples from wild birds admitted to the Raptor Center since the fall of 2022. And like the PCR study, we're collecting blood samples from as many birds as possible. It doesn't matter what they're coming in for or what species they are. If we can get a blood sample for this study safely from that bird, then we are going to get that sample. And Hawk Ridge has gotten blood samples for this research from birds that are being captured for bird banding during the fall of 2022, 2023, and 2025. And the picture in the lower right of the slide shows what the testing plate looks like when you're doing the serology test. So the wells that are clear instead of blue are the ones that are positive. Okay. So there are very few previous research studies that have looked for antibodies to highly pathogenic avian influenza viruses in raptor species. The studies that have been done did not find many, meaning that the birds they tested had not been previously infected with HPAI and survived that infection. So their immune system did not have any memory of the virus, and they didn't have any antibodies to HPAI in the blood. There are a few research studies that report what type of clinical symptoms raptors infected with HPAI viruses develop. These reports include birds who were naturally infected with the virus and some studies where birds were experimentally infected. And in these reports, most of the birds became very sick and died. So, with these two pieces of information from previous research, high mortality, so lots of death in the infection studies, and few antibodies, meaning previous exposure to the disease in living birds, it seemed like most raptors who are infected with HPAI die from the disease. Oops, my computer is being very touchy. So, why are we collecting samples for this HPAI disease epidemiology research from two different populations or two different groups of raptors? So, the primary reason is we are trying to get the best overall representation of this disease in Minnesota's wild raptors as we possibly can. So the birds that we're sampling at the Raptor Center are birds that are injured, sick, or orphaned and are in need of medical attention. So these birds are not healthy at the time they arrive to the hospital. And because there is something wrong with these birds, it's what is called a biased sample of the raptor population. So, for example, it's possible that we are more likely to get birds that are sick with HPAI into our hospital because they're not acting normally and they can be caught by humans. So, because of this, the rate of positive birds in our hospital may not accurately represent what's going on in the wild population as a whole. So, we cannot say things like 5% of bald eagles admitted to the Raptor Center were infected with HPAI. Therefore, 5% of wild bald eagles in Minnesota are infected with HPAI. We can't say that. It's two totally different populations. So the samples collected from our wildlife rehabilitation birds give us information about the birds that are coming in for rehabilitation and only that population of birds. The birds being sampled at Hawk Ridge Bird Observatory are healthy wild raptors. These are birds that are exhibiting normal behavior and are actively migrating during the fall. So the birds are tracked for research that's focused on learning more about the natural history and populations of these birds. They have the metal leg bands placed, and samples are collected, measurements are taken, and then the birds are immediately released again. So being able to get samples from these two different populations gives us a better overall picture about how this disease is impacting Minnesota's raptors. So now let's go on to looking at some of the results from this research. So the results of our PCR surveillance work at the Raptor Center are publicly available on our website. So if you want to go look at these graphs in more detail, you can find them online, and the link is here on the slide. So this figure summarizes the number of National Veterinary Services Laboratory, or NVSL, confirmed HPAI positive raptors that TRC admitted from March 28th through December 31st in 2022. So the bottom, or the x-axis, is time divided into weeks, and the y-axis is the number of HPAI positive birds. So in total, we admitted 213 positive birds into our wildlife rehabilitation hospital in 2022. We admitted the majority of our positive birds in 2022 at the start of the outbreak during spring migration, so from the end of March to the end of May, with 43 positive birds being admitted the week of April 25th through May 1st. So this bar graph summarizes our entire disease surveillance for 2023. So the x-axis is again in weeks, and the y-axis is the total number of birds tested. So birds that were negative are in the gray and the black. So it just gives you an idea of how many birds we're testing on a weekly basis. And then the PCR positive birds are the dark red. And the weeks where we have a PCR positive, meaning a bird that's actively sick with the disease, I've marked those with the red arrows. So in 2023, for the entire year, we admitted 10 individuals that were confirmed positive for HPAI. So dramatically fewer than the 213 we had the year before. And these birds were spread out throughout the year, with most cases occurring in spring and fall and winter, kind of around migration, with no cases over the summer. In 2024, we had two positive birds in January, and then we saw nothing until late November into early December, when we had an increase in disease prevalence with 12 positive birds admitted within 6 weeks. And that trend of a slight increase in the number of HPAI positive birds that was seen in late 2024 continued into early 2025, with 8 positive birds admitted in the first 2 weeks of January. So this increase in cases coincided with a new genotype of the virus that began circulating in wildlife, and that was the D11 genotype. So in the fall of 2025, we documented the reoccurrence of HPAI in our wild raptor population earlier than previous years, so this past fall, with our first positive wild raptor admitted on September 6th. So the preliminary avian influenza positive cases are the gold color. So those are samples that have tested positive at our research lab and the state diagnostic lab. But each test is tested 3 different times to make 100% sure that it is HPAI positive. And that National Veterinary Services Laboratory test is the final confirmation. So these ones were still pending when I made the presentation. So next, let's move on to the serology results. I have that on for later. So this is the blood test that looks for antibodies. So a positive result on a serology test means that the bird was exposed to an avian influenza virus in the past, and their immune system responded to that infection by producing antibodies. So we'll start with what we found at the Raptor Center. So far we have complete results for birds that were admitted to the Raptor Center from September of 2022 through April of 2023. We have all of the samples from May 2023 to present to still analyze and get even more information. So this is just kind of the start of the data that we have kind of complete results for. The serology analysis involves 2 rounds of testing. So the results in this table are from the first round. So a positive result on the first round of testing means that the bird has been exposed to some type of avian influenza virus. It does not tell us exactly which type that the bird has antibodies to. It could be a low pathogenic strain, or it could be a highly pathogenic strain. We don't know. It's just some sort of avian influenza virus. So we have the species that we have tested in the left column, how many birds in total were tested, and how many birds were positive for that general screening test here, and then that's divided into percentage on the far right. So some of the most interesting results are for the bald eagles at the top. So during this time frame, we collected samples from 97 individual bald eagles, and 69% of the birds tested positive for general avian influenza antibodies. Other species that had a relatively large sample size during this time frame were barred owls and red-tailed hawks. So we tested 57 barred owls, and 7% of them, or 4 individuals, had general avian influenza antibodies. And we tested 63 red-tailed hawks, and 12.5% of them, or 8 individuals, had general avian influenza antibodies. So in these 2 species, the prevalence of antibodies to some sort of avian influenza virus was significantly lower than what we saw in bald eagles sampled during the same time frame. And then at the bottom is a list of all the species where we tested their blood, but every single bird we tested in this time frame was negative for antibodies. So any sample that tests positive on the first general avian influenza screening test is then sent to our collaborators at the University of Georgia for more advanced testing. So at the University of Georgia, they can run a test that can tell us if the antibodies detected in the blood are specific to H5N1. So are they highly pathogenic avian influenza specific antibodies? So this table summarizes the results from that second round of testing, broken out by species. So for the bald eagles, of the 67 individuals that were positive on the general avian influenza screening test, 52 of those birds were confirmed to have antibodies that were specific to H5N1 HPAI. So if we convert that into percentages, that means that 77.61% of bald eagles that tested positive on the general screening test also tested positive on the H5N1 specific test. And 54% of all bald eagles tested had antibodies to HPAI. So let's also look at the barred owls and the red-tailed hawks. So of the 4 barred owls that tested positive on the general screening test, only one of them had antibodies that were specific to H5N1 HPAI. So again, if we convert it into percentages, 25% of the barred owls that were general screening positive were high path specific antibody positive, and 2% of all barred owls tested were HPAI antibody tested positive. Of the 7 red-tailed hawks that tested positive on the general screening test, 3 of them had antibodies that were specific to H5N1 HPAI. So in percents, 43% of the red-tailed hawks that were general AI screen positive were HPAI antibody positive, and 5% of all red-tailed hawks sampled were HPAI antibody positive. So this table is a summary of all the samples that have been collected from healthy migratory birds at Hawk Ridge to date. So samples have been collected from 12 different species. 51 birds were sampled in 2022, 50 in 2023, and 78 individuals were sampled this past fall. We did not get PCR tests in 2022. We just forgot, so that was a miss on our part. But all birds were PCR negative in 2023, and our 2025 PCR tests are still pending. So this table is the serology results for the 2022 and 2023 samples from Hawk Ridge. Only 2 birds had antibodies on the general avian influenza screening test, 1 American goshawk and 1 red-tailed hawk. Both of those birds were trapped and banded in 2022. So the goshawk did not confirm as HPAI specific antibodies. So that bird had been exposed to some sort of low pathogenic strain of avian influenza. But the red-tailed hawk did confirm as HPAI specific antibodies. That individual was an after second year bird of unknown sex that was trapped and banded in 2022. And that bird's band number is on the slide. So from the Hawk Ridge samples, 3% of all red-tailed hawk samples were positive for HPAI specific antibodies. And that's very similar to the 5% of all red-tailed hawks that were tested at the Raptor Center that were HPAI antibody positive. So that prevalence percentage is very similar between our 2 sample populations. So we'll see if that trend holds true as we get more samples analyzed in the future. So let's review what the results we have so far have been able to tell us about the disease epidemiology of this circulating strain of H5N1 HPAI in North American raptors. So first, let's talk about the PCR test results. So this is the test that tells us if the bird is actively infected with the virus at the time of sample collection. So it tells us about disease prevalence or disease frequency within the sampled population at the time the sample is collected. So we have seen a very clear seasonal trend in disease prevalence in our raptor patients. So after that initial arrival of the disease in 2022, where there were many cases all at once, we generally do not see cases in wildlife rehab during the summer. We admit HPAI positive birds in our wildlife hospital from the fall through the spring, including the winter. So, the most likely reason for this is that birds of all species are grouping together for migration in fall and spring. And when animals are grouped together, disease transmission increases. So, I'm not sure why we continue to see cases throughout the winter, which is a non migratory season, because we don't see cases in the summer, which is also a non migratory season. I don't know why there's a difference between the two. We have also seen that the overall disease prevalence has decreased over time in our sampled population. So, this likely reflects an increase in overall population immunity in all wild bird species. So, as birds are exposed to the virus and survive infection, their immune system produces the antibodies, and that immune system develops a memory for that disease, which decreases the chance that the bird will get sick a second time with the same disease. So, the overall number of birds that are actively sick goes down. And this decreased prevalence we're seeing in our raptors is also being seen in other species as well. So, when new genotypes of the circulating strain of H5N1 2344B start circulating in wildlife, we still sometimes see a small increase in disease prevalence in our wildlife rehab patients. So, we saw this in 2024. We had those two birds in early January 2024, and we hadn't seen anything until the end of November when we got one case. And then in December, we started seeing 3 to 4 cases per week, which is a pretty decent change in the pattern that we had been seeing. And that increase in cases ended up correlating with the arrival of a new genotype called D11. So when that H5N1 virus develops a new genotype, it sometimes changes how virulent the virus is. So meaning that new genotype can sometimes have changes to the virus that causes birds to get more significantly sick when they're infected with it. And the last thing we've learned in our PCR screening is that the viral genotypes we are detecting in our wildlife rehab patients are the same genotypes that are seen in wild bird disease surveillance. So the graph on this slide is from one of our scientific publications, and that publication citation is listed here. And what this figure is showing is the overall prevalence of different H5N1 virus genotypes in wild bird populations. So the rectangular bars are the samples collected from the Raptor Center, and that continuous mountain-shaped graph in the background is samples from all wild birds in the state. And then the different colors and different textures that are outlined here, these are all different genotypes of that strain. So primarily what you're looking at is the color and texture patterns between the rectangular column. So the genotype we're seeing in the Raptor Center, which is the different colors, and the genotype that's being seen in the wild birds, which is the hill of mountain pattern in the background. And what we're seeing is that the prominent genotype that we're seeing in our wildlife rehabilitation patients is the same most prominent genotype that's being seen in wild bird sampling. And when a new viral genotype starts to show up in wild bird surveillance, it also shows up in our wildlife rehab patients. So this really confirms that samples taken from wildlife rehabilitation patients are a valuable addition to population level disease surveillance in wildlife. And that's great to know because it's relatively easy to get samples from these birds at the time of admission to the hospital. They're already contained, they're in human care for some reason, and trapping wild healthy birds to collect samples for disease surveillance is difficult in some instances. So from the serology results, we have learned that more raptors are surviving exposure to HPAI than we originally expected. Based on the previous research, we thought that the majority of raptors who were infected were going to die. But with bald eagles especially, they have a very high prevalence of seropositivity. So 54% of the bald eagles tested at the Raptor Center from September 2022 to April 2023 had H5N1 specific antibodies in their blood. So all birds that were antibody positive during this time, they were PCR negative. So they were not actively sick with HPAI at the time that we drew that blood. We don't know when they were exposed to the virus in the past. Given that sampling time frame, it's likely that most of those birds were exposed when the virus first arrived to the state in the spring of 2022, when there were lots and lots of sick animals in the environment. But it's definitely possible some of the birds were exposed later, though. We really have no way to tell that. And we don't know if a bird that is antibody positive, we don't know if they were sick when they were infected in the past. We don't know what type of clinical signs they developed. We don't know how severe those clinical signs maybe were or weren't. We have no way to tell that. And we don't know how long antibodies last for either. And we don't know what amount of antibodies in the blood will prevent them from getting sick in the future. It's called a protective titer. We don't know what that is in our raptor species either. So there's a lot we still don't know, but this in its of itself was very surprising to find. So this research is ongoing. We have grant funding to continue both the PCR and the serology testing at the Raptor Center and Hawk Ridge through 2027. So as we continue to collect samples, some of the information we're expecting to gain includes detecting changes in disease prevalence and antibody prevalence over time. So this high-path AI outbreak is different than any previous HPAI outbreak in wildlife that because it has persisted for so incredibly long. So this is really uncharted territory. It will be really interesting to see how the PCR and serology positive numbers change over time relative to each other. So typically what we would expect is as antibody numbers go down in wildlife population, the number of PCR positive birds or the birds with clinical disease will go up. And then as antibody titers go up, the number of PCR positive birds goes down. But we'll see if that trend holds true or not with this virus over time. As we get more samples, we'll be able to better say if there are true differences in disease epidemiology patterns between different raptor species and between different age classes within the same raptor species. And in the moment, PCR testing of raptors as they enter wildlife rehab is a very effective tool to detect the disease presence in the region where the bird came from. So this type of disease surveillance is very beneficial to the poultry industry as well as other people in the community, like people with backyard chickens and other people who work with wildlife. There's limited funding and resources for wildlife disease surveillance through state and federal agencies. So the testing that we're doing at the Raptor Center is one of the few ways we have to track this disease in our state. So kind of to wrap up, I'd like to acknowledge the people who've made this work possible. So all of the Raptor Center staff and volunteers who help care for the birds and help collect samples. We have several key collaborators at the University of Minnesota that have helped us complete our work, including Dr. Carol Cardona and Christelle Mendoza. So Christelle's the lab tech who runs all these samples for us. And Dr. Arno Winchman is a pathologist who's collaborated with us a lot on our high-path AI work. The great Hawk Ridge staff and volunteers who've been willing to collaborate on this work and get some great samples for us. And the University of Georgia, who runs the serology testing that's specific to the H5N1. And the funding for this research has been provided by the Minnesota Environment and Natural Resources Trust Fund through their granting program. So with that, I would be happy to take any questions.
Awesome. Thank you, Dana. That was so informative. I learned a lot about avian influenza strains and genotypes. So interesting and complicated.
Yeah, it took me a
Um,
while to figure it out. It's very confusing.
yeah. Feel free to put some questions in the chat. I see we've already got a couple of questions, and if anyone then has any other questions, you can feel free to unmute. But let's start with the chat questions. So Lindsay asked, I'm curious about the wells on the PCR test that look light blue in the middle and top
Mm.
of the test wells. What does that indicate?
Sorry, I hope I don't make anyone car sick here. This is the best way I know how to get back to it with the way my screens are set up. So the way this test works is it creates a chemical reaction that makes different kind of levels of this blue color. So in this bottom corner of the plate, we have this perfectly two clear wells, which are the positive control, and then the two negative controls down here that are the darkest dark blue. And then this plate goes through a machine and it measures light refraction basically through the machine and it puts a number value on it. So we have a cutoff to say, less than certain value is considered positive on this test. So like the light blue one, like these two, probably, if I had to guess, would make the cutoff as being a positive sample. This one's positive, this one's positive. And this one, it's not quite as dark as the other ones, but it's not light enough to be positive. So it goes through machine, it gets a number put on it, and then through lots of fancy testing that I don't completely understand, we have cutoff values that say positive or negative. Hopefully that answers your question.
Got a thumbs up.
Okay, cool.
Um, Kelly has a just a kind of a comment question that uh, she's a raptor bander and is interested in this kind of work. If you're ever looking for more people to collect samples, she's located in Southwest Iowa. If you have any connections of people that might be worth reaching out to.
Thank you for sharing that.
And then Kaya says, thanks, Dana. Very informative. Wondering if you've got any of the results back for the Hawk Ridge bird sampled from this past fall.
Not yet. The PCR tests um, we're still waiting to run those. We've been prioritizing our hospital samples, so those ones haven't been run quite yet. And then we're still working our way through all of the blood samples. I was working on our annual report for all of our research permits this afternoon, and I think we've gotten like 900 some serology samples from our wildlife birds. So it's going to take us a little bit to work through all those samples. So nothing quite yet. But as soon as I have things, I'll share it with Emily, and I'm sure she'll share it with you all.
Yeah, yeah. Kaya is one of our seasonal staffs that help collect some of these samples. So thanks, Kaya. Lindsay has another question. I'm just curious about the higher numbers of eagles versus other raptors. Do you have any theories as to
Yeah.
why that might be what they eat, other things?
Great question. The other thing we saw in the Eagle data is if we broke it down by age, adults were more likely to have antibodies than juveniles as well, which was also interesting. So possible theories. So these are all guesses. We don't actually know for sure. But part of it relates to their natural history and their diet. So kind of what you were thinking, Lindsay. So eagles, they are opportunistic. They scavenge, they fish, they will eat what they can catch. Um, but they are also a species of raptor that will hunt ducks and geese. And sometimes you'll see, they'll try to catch the cormorants and the diving ducks. So they're stalking them and trying to catch them. So they are a species that will naturally hunt and eat waterfowl, and they are scavengers. So if there's a big die-off from HPAI positive animals, they're not going to let a free meal go to waste. So they're going to take advantage of it, which means they're more likely to get exposed. Um, so the diet is probably the way they're getting exposed because they do eat those waterfowl and shorebird species that are more likely to be infected and they scavenge. The kind of second component to the question is why do eagles seem to maybe be surviving the infection more than other species? And I have no idea why that is. Is it that because they eat waterfowl, they've been exposed to low pathogenic avian influenza strains and maybe their immune system gives them partial protection? Is it something related to their species? I have absolutely no idea exactly why. Um, It's going to be very interesting to see now that we kind of beef up our sample numbers. We're going to get a really good representation of these species in our region with such a high sample size. Um, so it'll be very interesting to see how it plays out. Bald eagles are a very common species in our area. They're often our most common species we admit in rehab. But red-tailed hawks and barred owls and great horned owls are also very common for us, and they don't have that same seroprevalence. So it's a great question that we don't quite have the answer to yet, but we'll see if we ever figure it out. The immune system's very complex as to how it like why does one bald eagle survive infection and one doesn't? Like it's so hard to tell. The body is such a complex system. It's really hard to say.
Any more questions in the chat, or anyone want to unmute and ask a question? I have a question.
Right.
While everyone else thinks. Um, I'm curious what kind of recommendation you would give to people who are working with birds in the wild, to help, kind of prevent this spread of HPAI in the work that they do.
Yeah. So in the part of it, so it kind of the decisions you make with regards to controlling HPAI or any sort of disease transmission, it's kind of based on the risk level with the population you're working with. So, banders who are working with healthy migratory birds, you're at much lower risk of encountering HPAI than I am when I'm working in birds in a wildlife rehab setting or coming in. Um, that we do as people when we don't want to get the flu when the flu's flying around in schools and stuff this time of year. So washing your hands, keeping your equipment clean, wearing nitrile gloves, and you can use hand sanitizer on your nitrile gloves so you don't have to get it on your hands 5 million times a day and dry your hands out. You can hand sanitize your gloves to try to just keep things clean. So objects that you touch can spread the disease, dirty hands, things like that. Jill mentioned that um, about how HPAI can spread in air. So it's part of it. So the when birds are sick, they shed avian influenza virus in their oral secretions and in their feces. Um, and the and there's also differences too if you're talking um waterfowl that are in a water situation. If you're talking dairy cattle, that's a whole other situation. In our hospital, we have had positive birds directly next to negative birds, and they have not infected each other. So in raptors, it does not seem to be highly airborne, but raptors are also not an amplifying host. So there are species that tends to get sick with it, and then they don't get as high of a virus load versus a chicken or a waterfowl species is an amplifying host, which means they're shedding more of the virus, which means it's more likely to be airborne in those species than it is in a raptor. So you really have to kind of sit down, think about all of the variables, what species you're working with, what population you're working with them in, what environment, like are you cleaning up poop where you're using a hose and you're aerosolizing poop everywhere, and that's going to make a big disease transmission risk. But for bird banding specifically, cleaning your hands, cleaning your equipment between birds is a great way to prevent any sort of disease transmission.
Yeah, thanks for that. And Lindsay asked the question, what types of precautions does Hawk Ridge do when they are banding and collecting samples? This is kind of why I asked, because currently we don't really take any, higher level of precautions, to prevent the spread. And it's something that we're working on creating a protocol for that can be used into the future to, you know, uh, be a bit more conscientious of what we're doing with the work that we're doing. So yeah, good question.
And you're working with a very low risk
Yeah.
population. Um, and and it's also hard to disinfect things in December when it's frozen. So that's also just realistic.
Yeah.
Oh, I see what you're saying, Jill. Got it. It still prompted good conversation though.
Okay, yeah, and Kelly mentioned we Clorox wipe our cans between birds and only keep one bird in the blind at a time. But our cans are starting to rust because of it. Is there any other materials that you'd recommend, Dana, for like disinfecting supplies?
Clorox wipes, bleach works good for influenza. We use an accelerated hydrogen peroxide. It's called Rescue, but any sort of like hydrogen peroxide wipe works really well. It's nice because it doesn't have that chemical smell to it, which is really nice when you're working with birds. It will also ruin your equipment over time. Um, so if it's use like a PVC pipe or something that's not metal for your little Sharpies or something, that might be easier and more durable.
Yeah.
Chlorhexidine doesn't, I do not think chlorhexidine kills influenza viruses, but I would have to double check. Whatever product you want to use for disinfecting, it will have a fact sheet for it that tells you exactly what bacteria virus it is effective against. And the other thing it will tell you is the contact time. So the amount of time that the disinfectant has to sit on the surface in order to kill that infectious agent. So for example, some viruses have protective envelopes around them, like parvovirus does or December virus does. So you have to have a longer contact time than you do with an influenza virus that doesn't have that protective envelope around it. Good questions.
Any other questions? Oh, yep. Question, how long is the virus active outside of a host?
I don't know exact like hours off the top of my head, but I know it does depend on which environment or surface the virus is on or in. So for example, spring and fall, where it's cool and wet, the virus can live for a very long time outside the host, and freezing does not kill avian influenza virus either. Um, but I don't know exactly off the top of my head.
Well, we're getting close to 7 o'clock. If anyone has a final question they'd like to ask, otherwise, I'm sure Dina is available to answer emails and all of
Yes.
that. Yeah, yeah, good about the plastic containers versus metal. Yeah. Well, thank you so much, Dana, for taking time out of your busy schedule to give a presentation. We really appreciate it, and it's really important work, and we're very happy that Hawk Ridge gets to be a part of it. And thank you to everyone who came tonight and engaged in a discussion. Really appreciate it. And this is just the first of 4 talks that we're going to have this winter. And the next one is coming up in 2 weeks from today on January 20th at the same time, and it will be Conserving the Broadwing Hawk from Canada to Colombia with Dr. Lori Goodrich from Hawk Mountain Association out in Pennsylvania. So don't miss that one. Make sure you register. And of course, we are a nonprofit, like I said, at Hawk Ridge. So please support our programs by donating or becoming a Hawk Ridge member. And we hope to see you at more events like this. So, yeah, with that, I'll say goodnight and thank you, Dana. It's good to see everyone, even though I can't see you.
Thanks for having me. It was great to connect with you all.
Yeah, awesome. Have a great night.
Good night.